All right. Okay, so you will have a test on Friday. It's going to cover chapters 5, chapters 6, and the first part of chapter 7. Okay, so I'm going to cover more stuff from chapter 7. It will cover today's stuff. Okay, so that will be today's stuff. Okay. I know I haven't posted any homework problems from chapter 7 yet, so I will post a few homework problems, and you can expect that material will be covered. The rest of chapter 7 we will cover after starting next week. Let me have you guys settle down for a second, please. So the stuff. The other half of chapter 7 we'll cover next week. Okay, so you don't have to worry about learning stuff that we have not covered in lecture. I hope the lab is going okay, kind of, more or less. I got an okay sign there, so I'll take that as a good sign. I'm only doing one lab every other week, so I know some of the other classes they're doing labs every week, and I thought, feels like a lot. So anyway, okay, so I think chapter 5, chapter 6 is pretty good with you guys. Chapter 7, I hope is okay. So where we left off last week, okay? So last week. We left off, we talked about sampling distributions. Okay? And in particular, we learned about the sampling distribution of p hat. Okay? And so the idea is, there is some population exists with a proportion p, of p for things with a certain trait, right? So on Friday, our example was we had a tub of Reese's Pieces candies, and we said some proportion p of them are orange. So we said, maybe 30% of the candies in the tub are orange, or 40% of the candies in the tub are orange. We said there's some value p, okay? The sampling distribution of p the sampling distribution of p hat is the distribution of all possible p hats that can result from drawing a random sample of size n from that population. Okay? And we said, we talked about the central limit theorem. The central limit theorem, as it applies to p hat, says that p hat, our distribution of p hat, follows the normal distribution. You guys remember what the mean of this normal distribution is? I heard some people say stuff. Okay, is p and has a standard deviation of p times 1 minus p over n, right? Okay, and then we have a star, you know, as long as certain conditions are met. Okay, is this good? All right, then let's try out an example problem here. I guess I'll have to fire up our clicker machine. And okay, so let's say okay, so we will say we have a giant I don't know, bowl of M&M candies. Okay, and we know that in this bowl exactly 17.17 are blue. Okay, we will draw a random sample of 140 pieces of candy. Okay, and my question is, what is the probability that less than 15% of our sample is blue? Okay. Well, I guess before I have you guys go on, I just want to make sure this question makes sense. Okay. So the idea is, you know, we've got this big bowl, a giant bowl, I said, okay, and every time we take a scoop out of this bowl, okay, this is my scoop, we're expecting something around 17% of our scoop to be blue candies, right? But because it's a random sample, it's not necessarily going to be exactly 17% blue. Maybe it's more than 17%, maybe it's less than 17%. My question is, what's the probability that I get less than 15% blue? And that's the question here. Okay, I gotta figure out answer choices. And we'll see how you guys do. Okay. And I'll fire up our machine in a little bit. Oops. Okay, so the machine is running. You can click in your answer choices. All right, we'll say another, I don't know, I guess we'll go until we hit a minute 45 here or something. Okay, last call for clicks. Get your clicks put in. All right, so I'm gonna click stop here. Let's see what we have. Okay, so everyone's all over the place here. The correct answer is answer choice E though. Okay. All right, let's go through this. And we'll just make sure we are all good here, okay? So what we have from before is that we said p hat, the distribution of p hat, I should say can be approximated with the normal distribution, okay? Can be approximated with a normal distribution with a mean of p and a standard deviation of p times 1 minus p over n, okay? So what we have is that in our bowl, 17% are blue. So our population proportion is 0.17. You want to use 0.17 and not 0.15, okay? 0.15, this is the sample that we're asking about, okay? We also have that we have a random sample of 140 pieces of candy. This is going to be n here, okay? So our random sample is n. So what we have is that our distribution of p hats come from a normal distribution where the mean is 0.17 and our standard deviation is going to be 0.17 times 1 minus 0.17 divided by 140, okay? So I'm going to come over here and we're going to do this calculation. So I've got 0.17 times parentheses 1 minus 0.17 close parentheses divided by 140. I have to take the square root of this quantity, so I'm going to hit the square root answer button here. I have 0.0317, okay? This quantity right here is 0.0317. Now some of you got to this point, you saw this listed as an answer choice and said, ta-da, I'm done, okay? But that's not the case. This 0.0317, this is just the answer to p times 1 minus p over n. This is our, what we call our standard error or the standard deviation of the sampling distribution. So this is not our answer, okay? Because the question is, what is the probability that less than 15% of our sample is blue? So in our case, what we have is we've got a normal distribution. So let me just rewrite this. Normal 0.17 standard deviation 0.0317, okay? I've got a normal distribution centered at 0.17, and I'm coming down to 0.15, and I want to know what is the probability of being over here. Okay, so the next step in our process would be to do z is equal, I guess before I keep going, just want to make sure that this is okay. The question is asking what is the probability that less than 15% of our sample is blue. This is just like saying what's the probability that a randomly selected tiger weighs less than some amount. It's just a normal distribution problem. Once we've figured out p and the standard error, this becomes a normal distribution problem. So I'm going to do 0.15, basically my x minus the mean of 0.17 divided by the standard deviation of 0.0317. Okay, so I'm going to type this in, 0.15 minus 0.17 divided by 0.0317. I can type in that whole thing, or I can just hit divide by the answer button, and I get negative 0.63, okay, negative 0.62998. So negative 0.63, okay? And so if you picked either 0.63 or negative 0.63, these are z-scores, okay? These are not the correct answer. This is the z-score. So the last thing that we have to do is look up this z-score on our z-table and find the area. What we want is the area to the left. So we're going to look up z equal to negative 0.63 in the table, and what the table says is that the area to the left is equal, so the area to the left of negative 0.63 is 0.2643. This quantity right here, I think, that's in the 0.03 column, yep. So negative 0.63 is 0.2643. So the area to the left is 0.2643, okay? The question says, what's the probability that less than 15%? So we are happy with taking the area to the left. And that's our answer, okay? 0.7356, this is the area to the right. And so if the question says, what's the probability that more than 15% of our sample is blue? That would be 0.7356. Okay? So again, the concept is you've got this big bowl, and every time you draw from this bowl, you're expecting something around 17% to be blue, because we happen to know that in the sample, exactly 17%, I mean not in the sample, in the population, exactly 17% are blue, okay? But because of random chance, you might get more than that, you might get less than that, and so here our question is, what's the probability that I end up getting 15% or less? And that probability, well, it happens about 26% of the time. It happens about 1 in 4 random samples from the bowl. Okay. You just want to make sure conceptually we're okay with this? So this is our sampling distribution of p hat. Okay. Yes, question? What is the capital N? This capital N right here? This is just a shorthand way of saying normal distribution where the mean is p and the standard deviation is this quantity. Okay? So, I mean, I could write it all out and I can say the distribution of p hat follows the normal distribution with a mean of this and a standard deviation of this, but that is that would not be correct. Okay? You know, I did notice when I was looking at this thing, okay, more people chose B than C, okay? And B is the positive number, 0.63. Well, I guess people maybe, I don't know. You want to make sure you're doing your subtraction here correctly, okay? Where the quantity you're looking up always goes over here, and you're always subtracting off the mean. Okay. Well, we can try another one of these problems a little bit later. We have to cover this concept of checking for conditions, okay? So the central limit theorem the central limit theorem is pretty awesome in that, you know, here we're talking about some kind of distribution in a population of a categorical variable, and we say that when you look at the distribution of p hats, the central limit theorem says, you know, p hats come from a normal distribution, which is very handy to us because now we can apply all the stuff we learned in chapter 6 about the normal distribution to answer questions. Okay, there is come from a normal distribution, but we always said, you know, as long as certain conditions are met. Okay. And so here are the three conditions that we should check to make sure that the central limit theorem can be applied. Okay, so there are three conditions that must be true in order for us to use the central limit theorem. Okay, so the first condition is that our sample must be selected randomly. Must be selected randomly, and that also implies, or that also includes that individuals in the selected for the sample, individuals are selected independently of each other. Okay, so what we mean by being selected independently of each other, that means when one person is selected, it has no influence on whether another person gets selected or not. Okay, so you know, if we're talking about married couples or whatever, okay, if one person gets selected, if people are selected independently, if one person is selected, then that neither increases nor decreases the probability that the spouse is selected. Okay. In some cases, if people are not selected independently, maybe if you know, this person is selected, then his or her spouse has a higher chance of being selected, or his or her spouse now has a lower chance of being selected. That would not be independent. Okay. Independent means, you know, if one person selected this other person, it doesn't is not influenced, neither higher nor lower probability of being selected. Okay. Usually, if in the problem it says the sample is selected randomly, that implies also that it was selected independently of each other. But we can do that. Okay. Number 2, your sample must be large enough. Okay. There are 2 ways to check this, okay? To check if our sample is large enough, and this is kind of a rule of thumb. Some textbooks might use a different number. Our textbook, I think, uses 10. Well, I'm pretty sure. Okay. So to check, one way is both n times p has to be bigger than or equal to 10, and n times 1 minus p has to be bigger or equal to 10. Okay? So your sample size times the proportion must be greater than or equal to 10. And the other way, so sometimes you are given p, and sometimes you are not. Okay? So if you are not given counts, I mean, if you are not given P, but you are given counts instead, counts, then you must have at least 10 successes and at least 10 failures. So, you know, if we were talking about whatever it is, if you're going to take a random sample of M&Ms out of the bowl, okay, if you're drawing 140 M&Ms or whatever, you need to make sure you have at least, if you're given just counts, you need to make sure you have at least 10 blue M&Ms and at least 10 M&Ms that are not blue, okay? Or if you're not given the counts, but you're given the proportions instead, you just have to make sure n times p is bigger than 10, greater than or equal to 10, and n times 1 minus p, okay? Also has to be greater than or equal to 10. And number 3, this is the population must be big. Or conversely, the sample size cannot be too big. This is so the population must be big relative to the sample. So population should be at least 10 times the sample size, or conversely, sample size should not be over 10% of the population. Okay, so however you look at it, you don't want your sample to be too big relative to the population. This is rarely a concern, except when dealing with smaller populations. Okay, so I'm going to put up a series of 3 questions or 3 or 4 questions, and we'll decide if any of these conditions are violated, okay? And to help, I'm going to, I can type faster than I can write by hand, so I'm going to type out my questions here, okay. All right, and then I will turn on the clicker thing, and then you know, you'll input your answers for question 1, and then or the next one. Yeah, we'll figure it out. Okay, so we'll say scenario A. All right, so okay, an elementary school has 350 students enrolled. The administration wishes to know what proportion of students play sports, or we'll say after school sports. Okay, they randomly select from their rosters 50 students and find that 22 of them play after school sports. Okay, so don't shout out your answers. Violated, all right. Scenario B. So I'll post, you don't have to like scribble this down furiously in your notebook if you don't want to, okay? So scenario B, okay, so we'll say a company employs 1,200 people. They wish to conduct a survey of its employees. They randomly select 100 people and ask if they support the idea of a shorter lunch break to get off work earlier. 8 of the people surveyed said they support the proposition. Scenario C. Okay. Scientists wish to know what proportion of people have diabetes. Okay. They post advertisements in the newspaper and await responses. They get 850 responses, and of those people, I have no idea. I have no idea how prevalent diabetes is. We'll say 5% have diabetes. Okay. All right. So we will say your answer choices are, okay? So on the your clicker choices, here. Let's actually put this on a slide here. Okay, so I hope you guys got to think about these things, and you can. I'll give you a minute for each, or 30 seconds for each of these to think. So your answer choices. Okay. Answer choice A would be random independent condition violated. B will be large sample condition violated. C is big population condition violated. And D will be no conditions violated. Okay, all right, so we'll do scenario A first. We'll run this. So clickety clickety click. This is the elementary school. Which condition is violated? Random and independent condition, the large sample condition, the big population condition, or no conditions are violated. Okay, get your clicks in for this one. Okay, I'm gonna hit stop here. Okay, then we'll scroll down for scenario B. This is the next question. Oh, raise it up higher? Sure, I can do that. Is that better? Here, let me hide my face. And that's scenario B. Are any conditions violated there? Company employs 1,200 people. They wish to conduct a survey of its employees. They randomly select 100. Ask if they support the idea of a shorter lunch break to get off work earlier. 8 of the people surveyed said they support the proposition. Click, 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 click. Okay, last call for your clicks. Here we go. Okay, and then the last one, we'll do a scenario C. And we'll do this. Okay, this one seems to have given people less trouble. Okay, so we'll say get your last call for clicks for scenario C. Okay, great. Okay, let's see how we did. How do I do this? Okay, so we want to go to question 2. Question 2 was the elementary school scenario, and indeed the big population condition is violated. Okay, so for this elementary school, there are 350 students enrolled. So these students are our population. So let me copy this. Okay, so the 350 students are our population. We took a sample of 50 students, okay? So our sample, so this is our population. This is our sample. Sample size n. So n is 50. So our population is not 10 times bigger than 50, okay? So this needs to, our population should be bigger than 500, and it is not. So that's going to create some issues for us. We can check the other conditions. 22 of them play after school sports. 22 is bigger than 10, okay? The other number, if 22 of them play sports, then that means 28 do not play sports. This is also bigger than 10. So, this is play sports. This is our successes, and do not play sports. Okay, both of these numbers are bigger than 10, so we are okay there. All right, and it says it was selected. The students were selected randomly. So this is, that condition is also met. Okay, let's look at question 3. So here it says the company employs 1,200 people, and where did my clipper go? And they surveyed 100 people, okay? So the answer choice is B. Some of you guys selected D, saying no conditions were violated, but that's not the case. Okay, so a company employs 1,200 people. We have our population is 1,200. Our sample is 100. So 100 times 10 is 1,000, and our population is greater than 1,000. So we're good there. Okay. But we only have 8 people who said that they support this proposition. So we have 8 successes, and that means we have 92 quote-unquote failures. Okay? So this is not greater than 10. Okay, this one is greater than 10. Both have to be greater than or equal to 10. So large sample condition is violated. Okay, so that's scenario B. Is that okay, everybody? All right. Okay, and then our final one, scientists are the worst scientists ever. Do you want to know what proportion of people have diabetes? They post advertisements in the newspaper and await responses. This is not going to give you any kind of representative sample. So I don't know who is responding to these newspaper ads, but it will not give you a random sample. So those of you who selected that, that the random and independent condition is violated, you are correct. This sample is not random, okay? Because it says we're obtaining our sample via responses to newspaper ads. So this is going to be, suffering voluntary response bias. Okay, are there any questions on this? No? Okay, let me just copy this scenario into our notepad so you can have it in your notes. And I will just write not random. Okay, so on Friday's test, I'll have a few of these types of questions where I describe some kind of scenario and you have to say, this condition is violated or none of the conditions are violated. Now, technically, when you conduct inference in the future, you're always supposed to check for these conditions, but it's really hard to write an exam where you're supposed to check conditions and then, if they fail, you're not supposed to do any of the work. So it's hard to have some kind of exam written that way. So I've broken it apart into, this part you're explicitly going to check for conditions, and then everything else, the conditions are going to be met, so you can do the calculations. Because otherwise I feel like I'm writing you guys into traps. Anyway, that covers basically the stuff that you're responsible for Chapter 7 on sampling distributions. After the midterm or after the test on Friday, we will finish off the rest of Chapter 7 and Chapters 8 and 9 as well. So have a good day. Stay dry. Stay safe in the rain. We'll see you guys on Friday.